Ladies and gentlemen, come gather around, come gather around, come gather around. Today, we're building a CNC plasma table, and it works, and it only caught fire once, but we'll get to that. Built from a set of plans, from scratch. Let's go! The plans you purchase come with all the STL files and CAD drawings to build the pieces that you need. Some are out of plate steel, some are 3D printed. If you have access to a 3D printer, awesome. You can purchase the stuff already 3D printed by the seller of the plans. It costs about the same as a cheap 3D printer. Cheap 3D printers are that. I mean, there's a price point kind of thing. At work, I buy cheap printers, and when they cack, I chuck them. I don't even fix them. In this case, if I'm going to be buying a printer, I want to buy a better one. So this is a little bit higher scale than the cheap ones. Buy once, cry once kind of thing. I bought this one for this project, and I will have to find other things to 3D print to make the cost of this justifiable. Nevertheless, it's printing the parts that I need. This is the first piece I printed on a cheap printer. It took me a number of tries, and then I threw out the cheap printer, but that's why I bought this one. There's screw holes in here, set screws that hold the bearing shafts in place. They are printed the right size, like a tap drill size, and you just run a tap through it. So it works out fairly well. You can certainly create your own if you want, but the STLs are done, which is nice. So this is printed in PETG. PETG likes to be hot and an enclosed printer, which is why I bought this one. You can print them in other things, PLA, ABS, whatever excites you. I chose PETG. This is printed solid, so there's 100% infill to make it rigid and everything. And if you bugger the threads, that's fine. Helicoil to the rescue. I'll probably do a video on how to do helicoil. You can find one, I'm sure. So this is the first piece. I'm going to be printing 2 of these and whack other stuff. We'll see those in a moment. All right, back to the show. In theory, you shouldn't have to do supports when you print all of these, but I did. And I did end up running a tap drill just to clean up those holes, just in case they were not totally awesome. And it was pretty easy to just put a tap in a drill. A little bit of oil helps it thread really nice. And then you can zip through and thread all of these. Most of them are 1032 or 1/4 by 20. I did go for the extra feature of the Z probe, where the machine will go and find out where the metal is for every cut. This is genius. The plasma we have at work doesn't have that feature, and as the metal you're cutting warps and changes shape and does weird things, you got to constantly be there to adjust it. The framework is 2x2 square tubing. In here I'm machining sleeves for the bolts that hold it all together. There are 3D printable sleeves, but I thought I would be happier with steel sleeves. So no matter what you hammer your impact up to, this will not crush the sleeves. The plans come with 1-to-1 paper templates that you can glue right onto the steel that you have, and follow exactly where the center punch marks are and where to cut it and the whole thing. The point of this video is not to show every intimate detail, but to show kind of how it was put together. I cheated and CNC plasma cut a lot of stuff on the machine at work, all except for one plate. So I traced the one plate that I had onto another piece of steel and had at her. You can make them all using the templates that come in the plans. And if you just make them all by hand, and then your first job should be remaking them all with your new functioning CNC plasma cutter. The plans also call for making the whole framework out of 16 gauge 0.063 square tubing, and I thought that seemed flimsy, so I made it all out of 1/8 inch, because I figure, there's no kill like overkill. In theory, you should be able to fold the legs. The legs are actually quite short on this machine, so you can remove one bolt on each leg. The legs fold in towards the middle and do not overlap or hit, and then you can hang the whole thing on the wall, out of the way. Genius. Unless you built it out of 1/8 inch square tubing like I did, in which case I can barely lift that puppy. So I'm hammering in all the little sleeves to for bolting it all together.
I don't recall if I have a video coming up in here where I set up my milling machine to drill super accurately where all the holes needed to go. If you see right by that orange transfer dies and the one screwdriver on the table there, it's kind of like a corner of something out of plastic. That is a template that you 3D print, and it places exactly where the holes need to go on the legs. So you don't need any fancy jig. It comes with a printable fancy jig. That makes it so much easier for you. Here's my non-printable fancy jig. And I just set up my lathe, drill, mill, table saw. I set up this machine as a drill press and used my own kind of Tom Jiggery here to make sure I get all the holes in the right place. And then fun with the step drill. My drill press is not bolted to the table, and neither am I. Not to the table, the floor. So truthfully, you should never be hanging on to something that you're drilling, but step drills are pretty forgiving when it comes to thin stuff. And then I TIG welded all of the sleeves into all of the legs, and was happy with that. Fusion welded, so there wasn't very much filler to sand off. It just needs to keep it from crushing. That's all it's there for. I would probably make the table a little taller than the plans call for, just so it's not quite so short and on the floor. But I did end up put mine on a plywood kind of platform with caster wheels. You'll see that shortly. I would recommend drilling the holes 1 or 2 sizes bigger than the 3/8 that the plans call for the 3/8 bolts, just because you're probably not going to be able to drill to the 4 decimal places that you think you can get. At least I can't. It all goes together fairly well. All the hardware is accessible from any reasonably well-equipped hardware store. This is the Y-axis, the gantry that goes on the Y-axis. Again, all held together with a whack of 1032 screws. Once I got the thing placed, transfer punch to get the center punch marks in the right place, and then I drilled them all, tap in the drill and threaded them all, and then ran screws through them all. It seems kind of hokey to be 3D printing these parts, but it does seem to work. This is the little bracket that will hold the X-axis onto the gantry, and I TIG welded it just because I like that. When you weld, things do tend to shrink, and when I welded the reinforcement brace on the bottom of this, it did shrink a little bit, but with some significant beating with a cross-peen hammer, I got it to sit flat, or level, or flat. Flat, I guess. It's relatively easy to level this thing as well when you're assembling it, and the instructions lead you through it. You want to make sure that the torch does not get lower and lower and lower as it goes further and further and further away from the Y-axis. Don't need a lot of weld in here. The less weld you give it, the less shrink there will be. And you can always massage it with a hammer. The gentle persuader. There are 3D printable belt tensioner ends. And I printed them and then chose, no, I don't think this is what I want. And the plans include not only the STLs for the 3D printable ones, but also drawings to make yours out of steel, which I prefer. So I cut 2x2 angle. I think this is 1/8 inch thick, and made them into the tensioners. The one is stationary. This is 5/16 round rod, a couple 5/16 nuts. Pretty sure it's 5/16, and then just welded together, and it works really well. These are zinc-coated nuts. You do not want to weld on zinc-coated nuts. If you do, hold your breath. Welding galvanized coating is not good for you. You'll know you're welding it when it smells like sweaty onions. These were CNC plasma cutted at work. They were not the best cut that the machine at work has done, but they did come out for me. Pretty sure it's only 1/8 inch plate. Again, there are one-to-one templates that you can trace out, and it works slick. So here is the stationary bracket, and then these are the movable brackets, so you can adjust. I did use the given 3D printed adjusting screw holder thingy. Let's assemble the bearing blocks. They just use skateboard wheels. And I think these are 3/8 solid rod. And there are 3D printable plastic washers. I imagine the washers have a useful purpose. But I printed them and put them in there, and it's fine. I did add once the solid rods are in and holding the bearings in place, I did drill and tap, I believe, a 1032 Allen head cap screw just to keep these from slipping out and falling out. As I was trial fitting things and assembling them, the the rods that point to the ground would often find the ground if things weren't nice and snug, and I didn't like that. So since these were printed 100% infilled, it wasn't an issue to drill and tap wherever I wanted it to be. I would strongly recommend 100% fill, although I hear PLA does not like being 100%, but the PETG worked really well. There are set screws. You can see 3 in the on the other one, and 1 on a couple sides, and those just help you get these bearings zeroed to the steel so they sit and they don't have a whole lot of friction. You will need to overlook the fact that I'm assembling this thing backwards. Notice there is no reinforcement rib on the left-hand side. That should have been on the right-hand side. I'm spraying the whole thing with Rust-Oleum. I usually like Rust-Oleum? No, it's Krylon, I think. I used Krylon, and it's like I forget the color. It's like I don't know, it's gray, but it was a special kind of gray, I think a semi-gloss or something, and it's a primer and paint all in one, but it applied really nice. I think it's Krylon. At any rate, I like the color, so I printed. I do Tremclad, but I'm venturing off. Then I plunked a whack a coin down on Amazon, and I got stepper motors, stepper motor drivers, wire. The box of security cable is actually the wrong kind of wire. For whatever reason, I ordered non-shielded. You want all of your cabling to be shielded on this. There's the rods for the Z-axis to follow. There's relays. And when I bought these plans, this is the version 1 of the JD Garage plans. They are designed for an Arduino Uno, which I bought. It's like 40 or 45 bucks Canadian, and had issues with it. These plastic caps you can buy. I had to cut off the second rib because I used too thick of a tubing. If you just stuck with 16 gauge, you'd be fine. If you're smart, just 3D print them. I had issues with the Arduino. The software that you get included in the set of plans is Open Builds Control, which is common used for many CNC machines, but it no longer flashes Arduinos. And in trying to flash my Arduino, I apparently had the Arduino flash its last flash, and it no longer worked or responded to me. So the updated plans, which are the ones you can now get, are version 2, which have a couple little changes. Mostly they use an ESP32 board. So I ordered some ESP32 boards. And the nice thing about those is you can connect to your machine wireless or Bluetooth or USB. And so I flashed one for wireless, which I have had success with, and I flashed one for Bluetooth, which I have not yet been successful in connecting to. This is the adjuster. I just did a big long, I think it's 5/16 bolt, and I just threaded it all the way to the head. I did not buy a fully threaded bolt. I fully threaded it myself. The tooth belt comes from Amazon. Please overlook the fact that I'm installing the wrong stepper motor here. There's a longer, more torquey stepper motor that goes in this place. So if you're like, well, how come the motor I have is longer? Well, because that's why. And you can see I assembled the gantry so that I have the brace on the right side, but the wrong stepper motor. I changed it later. You'll see it later. This is the X-axis. Same kind of thing. Skateboard bearings, although I think these are a smaller diameter. And it seems kind of convoluted, but there's a bunch of extra little screws and threads that allow you to adjust how this thing sits on the Y-axis, X-axis rather. Plus there's a couple 3D printed risers, extra bearings, you got a bunch of bolts just to make it go in the tracks. The groove that you see on the side facing me is where the torch height sits, I think. Yeah. If you don't make the Z probing stepper motor kind of thing to make it find 0, your torch would just attach directly to that. Strongly recommend have this thing have the little extra stepper motor, which is what this bracket is for. It's pretty easy to put together. So the slotted holes allow you to adjust the placement of the bearings. So here it is all assembled, and it's just going to sit on the end of the tube like that, and then you just take up the play so it moves nice, no unnecessary friction. Top and bottom and sides, you can get it sitting level, although it probably doesn't matter, but you just want it to move nice. The top is going to have a stacked set of bearings, the plastic washers, and some fender washers to guide the toothed belt through here. So it's going to come along on the other side of those rollers and then come up towards you to go over the stepper motor. This is the Z-axis with the height probe. There are like linear bearings. I think I wrecked 3 of them trying to assemble this all together. Be gentle with those. That's about all I can say for that. I did make a change a little bit later on for the bracket that you see there, because this whole apparatus is right in front of the fasteners that hold it in place. So I later drilled and tapped new holes a little further apart so I can actually get at them. Still the short stepper, ignore that. I followed one of the videos that JD Garage did on why people find these things like sagging too much. And apparently it has to do with painting the tubes thoroughly. And there's just enough squish in the coating of paint that by the time you're at the far end of the X-axis, there can be a little bit of deflection or gravity or something. So he recommends not painting them at all. What I did is I followed his tutorial where you run some tape on the path of where the bearings go, paint the whole thing, peel the tape off, and then use gun bluing to coat the steel. Here's the whole assembled thing with the stepper motor and the sliders, and it all gets assembled together fairly well. I did have to grind a little bit off of the stepper motor threads so that it would all assemble. It was just a little bit too long. This is my initial wiring of the whole thing using the Arduino, which you see up in the upper left, and then I bought version 2 of the plans, 2 ESP32 boards, and then just went through rewiring the whole thing. Because you can connect wirelessly, I have a phone charger tapped into the power supply so that I can plug a USB into the ESP32 board right inside the whole case. It moved up from 1 relay to 2 relays. The wiring diagram is very thorough. Shows you what you need to wire and what you need to put together. And if you have 4 wires going to each stepper motor, if you use 5-pin connectors, you can run the sheathing, the metal sheathing can connect to your 5th pin to properly shield all of the stepper motor wires from interference. I guarantee you, your plasma cutter is going to introduce a fair bit of interference with the wiring. I did a remote e-stop on this. I did not want to kill the power button on the box. I wanted the box to be safe under the table, not attached to a leg, and have the e-stop easy to access. but I did not fully shield that wire and had to later, because it would just do the hippie shake shake, because the plasma cutter would turn on and the e-stop would go berserk. So I shielded that and that was fine. A lot of the wires were run under the board, but the shielded ones were not. This particular box came with a fan, and I was nervous about this fan. Like, is it a 5-volt fan? Is it a 12-volt fan? And this power supply is running 24 volts. So I kind of did the safety squint and connected the fan, and it ran, it's running, and it hasn't set fire yet. So I think we're good. I think the fan's a good idea. You may not need one, but I thought it would be a good idea. I have a Brother label machine. I love the label machines. If you have a tendency towards OCD when it comes to labeling, get a label machine. So labeling everything so I don't have to think about this in the future. Shielding all the connections. Oh man, I love wiring. And the ESP boards can plug into a breakout board, which make it super easy to do all your connections. And both of the ESP32 boards that I had a fried pin. You could see a black jumper on the top left there, because there was one ground that was not grounding, so I had to jumper to these connections to get to a ground. And here's my e-stop, and I believe I am wiring with the properly shielded connection this time. Or not. Oh, there's no ground in there. So I've yet to discover the shielding issue. The tray is for, it's an expensive option. It's a stainless steel tray that would normally go underneath your dishwasher, which will hold like 6 or 7 gallons of water, which hopefully evaporates quicker than it fills up, thus saving your floor. I felt that was a good idea, so I bought the tray. This is 2.5-inch angle, and I bought 2-inch flat bar, and then drilled a whack of holes down the side so I could have these spaced, I want to say 2 inches apart, might be 3. And I just cut with my horizontal bandsaw down to the sides of the holes that I drilled. You can cut these by hand, you can cut them with an angle grinder, but they fit in like this. I like the tray. I think it's a good way to go. And then we're checking the movement here. And then I thought, oh, I need to label this, man. And I love my labels. I should label the power switch. I ran braided sheathing all over all of the shielded cables just for style and bling. We've got X, Y, and Z. We've got the torch control, which plugs into the back of this plasma cutter. You can just open a box of an ordinary plasma cutter and find the switch connections and tap into that. You can, you also really should get a non-high frequency start plasma cutter, which I bought. I did a previous video of a really neat plasma cutter that I was looking forward to using for this machine, but a lot of comments were left saying, yeah, don't do that. So I chose to listen, and I bought a non-high frequency start machine. This is a little notchy. When I first got this thing moving, turned out I apparently can't set up dip switches properly. The 2-inch is just a little bit shorter or something. I had to attach this 1/2-inch bar at the bottom, but it's not all the way flush to the bottom. What I wanted is to have these things set up so that the 2-inch bar at the top, the plates there, are completely flush, so I can sit something across all of that. So that's why the 1/2-inch bar is there. And then we hook it all together. Lotos, they used to be like cheap plasma cutters, but they've been around for a long time, and they seem to be doing pretty good for quality. The machine came with that 220 volt 30 amp plug, twist lock one, but I don't have that kind of an outlet in my shop, so I just changed the end to a 50 amp welding plug. And then we got to try this out, man. Outside, just in case things go wrong. What could go wrong?
Don't do that.
The tray comes with foam rubber on the bottom, which will catch fire. Run some kind of water in there. Found some fellow who made a 3D printed machine torch thing for this very plasma cutter. So I paid the 20 bucks Canadian, printed it out, and then now I have a machine style torch on there, which you do have to jumper the safety switch to know that the nozzle's still on there. So as long as you're paying attention. And then here's my significant cut. It seems to be working okay. There's a little bit of love I still need to show it, but hey, this is my first interesting cut on this machine. So far, so good, man.
So I'm honestly pretty excited that it works. A few little teething issues along the way. There's some tweaking I need to do with it that I'll work out over time. But I mean, for putting the whole thing together and it cuts relatively painlessly, I'm pretty pleased. So it is a good set of plans. There is a fair bit of following people who have built these. It worked for me, so I'm pretty excited about that. If this intrigues you, there's a link below to where you can purchase the plans and build one of these for yourself, and then report back and let us know how it goes. Meantime, I got to figure out some stuff to cut with this, because like, who wouldn't? As always, thanks for watching. Take care, and we'll see you again.